Welcome to Open Walnut, your one-stop shop for all things cyber, cloud, and automation. With our tutorials and engaging content, we'll show you how to protect resources, leverage the power of the cloud, and automate your way to success. Let's get it cracking. Hi everyone. In today's lab, we will walk you through how to set up a static website using Amazon S3 bucket in combination with Amazon Cloudfront. Some of the prerequisites for today's lab are basic knowledge of AWS and Terraform, AWS CLI installed on your machine, and AWS profile configured with permissions to Amazon S3 and Cloudfront. Preceding the lab, however, let us discuss what these components are and why they're used in combination with each other in relation to security. Amazon Simple Storage Service, S3 in short, is a highly durable and available object storage solution. S3 accepts almost any type of data and has limitless storage capacity. Furthermore, S3 provides a range of security features such as access management, storage encryption, versioning, and file integrity. The benefits discussed so far provide confidentiality, integrity, and availability of data, which covers all three CIA principles. Last but not least, S3 gives us the ability to host static websites. Next up, we have Cloudfront, which is Amazon's content delivery network offering. Cloudfront ensures that your website's content is located as close as possible to the end user by replicating hosted files across various geolocations. As a result, users benefit from high availability and superior loading speed, which enhances the user's experience. Amazon Cloudfront comes with numerous security features, such as encryption in transit, geolocation restrictions, DDoS protections, and more. So how do these two services work together? Static web content is hosted in your private S3 bucket that is only accessible by Cloudfront. In this setup, Cloudfront acts as a proxy between the client user and the S3 bucket. Cloudfront then retrieves, also caching the content, and serves it to the end user. Using this combination, the S3 is not accessible by the public, which results in our files being secure. Prior to starting the actual lab load, let's set up our Terraform AWS configuration in the config.tf file. So let's create the file, config.tf. Within that file, we'll declare Terraform required version, which will be greater or equals to 1.011, required providers. Clearly does not want to do it for me. Within that, the only provider we're going to have is AWS, with source being HashiCorp, AWS, and version. Now double pastes, and version being greater or equal to 4.60, which is the latest version of AWS provider at the time of recording this video. Oops. Next we have our backend, which is S3. Within the backend declaration, we have bucket, which is tf backend open walnut, and it's showing us that we have an error. Let's fix that. Not sure why it was showing that we have an error. Next, we have to put our key. The key for this lab will be sec100.tfstate. Since we're doing the sec100 series labs, region will be US East 1. Our DynamoDB table, which I actually forget what it is. Let's do DynamoDB list tables to double check. The table is called tf backend, and paste that in. And next we will make sure that this file is encrypted. Okay, at this point our config file should be set up and we can test it by running Terraform init. As you can see, the backend has been configured successfully and now it's downloading the providers. While it's doing that, we can start working on the Terraform has been successfully initialized, And now we can start working on our actual code. So we will start creation of our resources with AWS S3 bucket, which will be the storage for our static website. We'll start by declaring the block for AWS 3 as can be seen on the screen now. Resource AWS S3 bucket. We'll call this bucket site origin bucket equals to, and sorry, I will explain all of this in a second in more detail. Site origin. And we'll do tags. I like doing tags just to keep my resources organized. So now we have created our first resource. Here we have declared a resource AWS S3 bucket. We gave it a local name, site origin, and then we called the bucket itself site origin as well. Furthermore, we have declared tags, and the only tag we assigned it is called environment with the value labs. So to sum all of this up, we have declared a resource of a given type, AWS S3 bucket. We have given it a local Terraform name, site origin, and we have also called the bucket site origin. This may be a bit confusing, and we have three different names now, so let's sum it up. AWS S3 bucket is the name of the resource block. It describes the type of infrastructure object we are creating. This site origin is a local name of the resource block. This is a way for us to reference the resource within other modules or resources within this file. And lastly, we have bucket argument, which is the name of our bucket once it's created in AWS. Now that we have created a bucket, we need to secure it. And we then start securing our bucket by blocking public access. To do this, we need to define a new resource of type AWS S3 bucket public access block. And considering this relates to the S3 bucket above, we will also name this resource site origin, just to keep it consistent. Here we have to provide the buckets that is going to apply to, which is our bucket above. Terraform had a really cool way of referencing resources within it. So as you can see here, we already have a resource suggestion, which is the resource above. From that resource, we need to grab the argument bucket, and now it will know exactly which bucket the policy applies to. So why would someone want to block public access to their S3, one might ask? In order to avoid exposing all of the objects in the bucket to the public, and only making certain folders with objects accessible to limited people or principals. In this case, from a public standpoint, only to Cloudfront. To make more sense of this, let's say we have three folders: folder A, folder B, and folder C. We only want the public via CloudFront to access folder A, where contents for our static site are hosted. Meanwhile, we don't want anyone to access folder B or folder C. We can specify this in the bucket policy, and only one folder is accessible to CloudFront. The other two will only be accessible to the AWS user. So far we have declared the resource, and we have declared which bucket the block public access will apply to. However, we have not blocked any access so far. So let's declare the arguments that will do that for us. So we'll block public ACLs. We'll set this to true. By the way, all of these arguments only have Boolean values, so either true or false. Next, we'll block public policy. Set this argument also to true. Next, we will ignore any public ACLs. And lastly, I will restrict any public buckets. Save this. So, as I mentioned, all of the following arguments either take true or false as their value. So let me explain them one by one. Block public ACLs indicates whether S3 blocks access control lists that otherwise allow public access. When the argument is set to true, it prevents setting buckets ACLs and objects ACLs within the bucket from allowing public access. It also prevents adding an object to a bucket if public ACL setting for the object is included in the request. Next, we have block public policy, which determines if S3 blocks public bucket policies for the specified bucket. Setting this argument to true instructs the bucket to reject applying a new policy if the policy allows any public access. Ignore public ACLs indicates if S3 should ignore new public ACLs applied to this bucket. If public access is granted by ACLs, the setting blocks it. However, the setting still allows adding an object to a bucket if public ACL setting for the object is included with the request, unlike block public ACL setting. Lastly, restrict public buckets determines whether access to a bucket with the public policy is restricted or not. When the argument is set to true, only AWS service principals and authorized users will be able to access this bucket, and nobody else. Next, we will enable another security setting, which is encryption. This one has a bit of a lengthy name. And again, we will name this resource site origin just to group them all up together. We will then copy this here, since we already declared it before. And within the rule portion, we will say apply server-side encryption by default, SSC algorithm, IIS 256. So, what does server-side encryption do? Server-side encryption allows us to protect our data at rest, meaning on a stable medium such as hard drive, disk, solid-state drive, or USB stick. If the data is not encrypted and the storage medium is stolen by an adversary, they will be able to read the contents of the data. However, in the same scenario, if the data is encrypted, the adversary will have a hard time decrypting it. AWS offers 3 different types of encryption that can be used on S3 bucket objects. These are server-side encryption with Amazon S3 managed keys, SSE3, which is what we're using here. However, here it's declared as IIS 256, which is what is used by SSE S3. Next, there is also an option of using SSE KMS, which is server-side encryption with key management service keys. And lastly, server-side encryption with customer-provided keys, which is SSE-C in short. We used SSE S3 for the implementation here. However, recently Amazon started encrypting all of their buckets by default, so now I'm wondering if this whole resource block is even useful anymore, for SSE S3 at least. However, as you can see, the arguments here are rather straightforward, so we can now move on. The last security feature we will discuss is versioning. So what does versioning do? Versioning doesn't necessarily make your bucket more secure. However, it does secure your objects from accidental deletion or overwrite. Whenever there is a modification made to the object or a new version of the object is uploaded, S3 will create a backup of the old version of the object, which allows us to go back in time and revert any file changes if necessary. The syntax for this is fairly straightforward, so I'm not going to explain it. Now that we have configured all of the S3 resources, we can actually use Terraform to create them. We can do that with Terraform apply. In production environment, I would recommend to do Terraform plan first, especially if you're new to Terraform. That way you can actually validate what Terraform is creating without having the risk to create or modify the wrong resource. As we can see here, Terraform is going to create S3 bucket resource, S3 bucket public access block resource, S3 bucket server-side encryption configuration resource, along with versioning. We can go ahead and press yes. Oh, interesting. So this error tells me that the requested bucket name is not valid, which means that somebody has already taken it. So let's change the name to site origin open walnut just to make it unique and try it again. So the S3 bucket name is supposed to be globally unique, so no one customer actually has the exact same bucket name. And there we go. Our resources are being created and all four of them got created. Now let's go to AWS and we can refresh the S3 page to see if our bucket got created. And here we are. We can see the bucket got created right here, site origin, open walnut. And if we go into the properties, we can see that the encryption is set up. As I mentioned though, this is already done by default by AWS. The bucket versioning is also enabled. And if we go to permissions, all of the public access is blocked. And we can see all of the four options were enabled right here. Well, looks like great success. Now that we have created the S3 bucket, let's create a simple HTML file that will serve as our static website proof of concept. So index.html, nothing fancy, just simple HTML code here. Now let's go back to our main.tf and we will create a W3 S3 object resource which will upload our index.html into our S3 bucket. Name it content, and it's on AWS S3 bucket site origin 3 dot bucket. Key would be index.html. Source will be index.html. I have an error here. Set encryption equals yes to 6. So this resource has a few different arguments that have not yet been covered in other resource blocks. So let's go over them. So first of all, we have our depends on argument, which, as you might have guessed, lets you specify dependencies this resource may have. Most of the time, Terraform is smart enough to figure out the order of creation of different resources itself. However, as an assurance, it is safer to use depends on and specify this order yourself. Granting that an S3 object could not be uploaded prior to having a bucket to be uploaded to, we specify that AWS S3 object depends on AWS S3 bucket resource. That's not the case right now because we already created the bucket, but I just wanted to show you a safer way to do things. We then have the key argument, which lets you specify the name of the resource once the resource is uploaded to the bucket. Next up is source, which is needed to specify the path to the file that is being uploaded. With respect to our project, all of our project's files are in the same directory. So we're simply using /file name as our path. If you choose to upload file from another folder, please specify the appropriate path for it. We also have server-side encryption, which matches the encryption that was specified on our bucket. Ideally, S3 is supposed to encrypt object automatically. However, when we first tried to upload the file, S3 simply denied us the upload, and after some debugging we found out that it was because of server-side encryption. Last but not least, we have our content type, and this lets us specify the content, which is text/HTML. If you don't specify the content, instead of the index.html being browsable, AWS will ask you to download the file, which we obviously don't want end users downloading the file instead of seeing our website. Next, we will create Origin Access Control resource, which is part of Cloudfront distribution. We're creating Origin Access Control first because Cloudfront distribution is actually dependent on this resource. So let's go ahead and create that. security pillar 100, S3, OAC. Origin control type will be S3. Signing behavior will be always, and signing protocol will be SIG v4. Most of the arguments are pretty straightforward. We have the name for our Cloudfront origin access control. We next have the origin access control origin type, which is our S3 bucket. We then have signing behavior, which is always signing behavior here refers to the process of generating signed URLs to control access to the served content and when the signing happens. In this case, it's always. And lastly, we have signing protocol, which is version 4. A signing protocol is a set of rules and procedures that govern the generation and use of signed URLs and cookies. This protocol specifies the format and content of the access policy, algorithms used for signing and verifying, and key management practices. It also ensures a level of authenticity and integrity of the content during transport. This is only one option, in this case is SIG v4. The next AWS resource we have to configure is Cloudfront distribution. It is rather a lengthy resource block, so I'm going to fast forward through typing the code. So now that the code has been typed out, let's go over it. So first of all, this resource depends on the creation of S3 bucket along with origin access control. Next, we have enabled argument, which simply states the distribution is enabled upon creation, while default root object tells the distribution which page to load first for the user when they enter the website. Next, we have default cache behavior, which describes how we want Cloudfront to fetch our objects from the S3 bucket. In default cache behavior block, we identify that we want Cloudfront to only use and cache get and head HTTP methods by utilizing allowed methods and cache method argument. Next, we have target origin ID, which is our S3 bucket, and we want Cloudfront to only use HTTPS protocol to fetch the page. Next, we have forwarded values, which in spite of us not employing queries or cookies on our website, Terraform still requires us to apply this block, with query string argument and cookies blocked within it. Each of this set to negative values. So as you can see, false here and none here. Oh, I think I made a mistake, and maybe it's supposed to be query string like this. Next, we have origin block, which specifies where Cloudfront should fetch our static website resources from. It consists of quite a few arguments. However, we will only be using 3 of them here: domain name, origin ID, and origin access control ID. The first 2 of these resources get information about and point to the S3 bucket, while origin access control ID links the access control policy to the distribution being created. That's the resource we created in the last part. Next, we have restrictions. The only restrictions that Cloudfront currently offers is the geo restriction. The geo restriction has 2 types: whitelist and blacklist. Blacklist would block all the clients from specified countries from being able to view the website, while whitelist, which is what we're using, allows clients from only the specified countries to be able to view our website. Whichever list of the countries is the shortest and would be the easiest to maintain is the method that should be used. Lastly, we have Cloudfront distribution, a requirement, which is viewer certificate block. It states the default TLS configuration for our website. Since we're using Cloudfront domain name, the only argument we specify within the block is Cloudfront default certificate, set to true. This argument allows clients to use HTTPS to request objects from our website. The final step that the setup requires is declaring IAM policy that allows Cloudfront to obtain files from the S3 bucket. So let's go ahead and create it. So in the statement part, we have should effect equals to allow actions array. Here we have just one action, S3, get object. Then we have principles, cloudfront.amazonws.com, type equals service, resources, which would be ARN, AWS, S3, and then we can declare the rest of it like this. Next we have condition test equals string equals variable will be AWS source ARN, and lastly we have values, which will be equal to AWS CloudFront distribution dot site access dot ARN. Then we also have to create another resource, which is AWS S3 bucket policy. It weirdly did not populate. This depends on is really not necessary, but I'm going to put it here anyways. Policy document dot origin. Not sure where I wrote origin here. It should be site origin, just to be consistent with the rest of the S3 related resources. We have bucket AWS S3 site origin.id, and we have policy equal to data. There we go. So let's go over this. AWS IAM policy creation is composed of two different resources. We have AWS S3 bucket policy, and we have AWS IAM policy document. Due to AWS S3 bucket policy being dependent on AWS IAM policy document, let's go over that first. AWS IAM policy document contains the actual context of the policy and begins with the statement block. There can be multiple statement blocks within IAM policy. However, we only have one in this tutorial. In the statement block, there is an optional SID argument which allows the user to define a statement ID. SID can be used to clarify the intent of the statement. So in our case, it would be the S3 Cloudfront static website. Next, we have effect argument, which defines if the statement is of allow or a deny type. In the actions argument array, we specify which actions are allowed to be taken. In this instance, we want Cloudfront to be able to obtain objects from the S3. Next, we have principles block, which contains two elements, identifiers as an array and type as a string. Principles block defines whom the statement applies to. You can specify principles block multiple times within the same statement block if you have multiple principles, just like you can have multiple statements within the same policy. In this case, we only specify one principle, which is Cloudfront Amazon AWS.com. And because it is an AWS service, the type is declared as service. Resources argument declares which resource or resources this statement applies to. This would be all of the S3 buckets content. Lastly, we have the condition block that allows Cloudfront to access the buckets solely when Cloudfront distribution makes a request that contains S3 origin. Conditions block consists of three elements. Test, which defines the IAM condition operator, variable, and value, which define the value of the string for the condition to be met. I just noticed I forgot to actually put dash star. That way our Cloudfront distribution can actually access everything in the S3 bucket. Now that we have configured all of the resources in Terraform, let's run Terraform plan and then Terraform apply to create the resources in AWS. This takes a few moments. It needs to acquire the state log file and then plan our resources. As you remember, we already created some of the resources in the previous part. So here it will be creating the IAM policy, also our Cloudfront distribution, followed by our Cloudfront origin access control, and finally the AWS S3 bucket policy itself, along with uploading our object, which will be the POC for our website. So let's go ahead and do Terraform apply. Sometimes, even though the Terraform plan does not give you any errors, Terraform apply might. And sometimes they occur prior to entering yes, and sometimes they occur after. Well, hopefully everything that we configured is correct, and this should go through. Cloudfront distribution typically takes the longest to deploy, so I'm going to fast forward through this. As we can see, it took about 3 minutes to complete the creation of the Cloudfront distribution, so now all of the resources are created and we can go to our Cloudfront. So if we go to Cloudfront, being a bit slow. And here we can see that our distribution was created. We can see the origin, and we can see the Cloudfront domain name. So if we click on our Cloudfront domain name, it should take us to our website. Oops, I did not copy that, I believe. And here, as you can see, it took us right to our website. We see the exact same content that we have put into our index.html file. And yep, our static website concept succeeded. Now that we have successfully created all of our resources and we see that the concept works, we can then start populating the website with useful information. However, at this point, this lab is over, and before finishing the lab, make sure you run Terraform destroy to destroy all of the resources that's been created. That way, you don't rack up unnecessary charges for these resources. That can be done with Terraform destroy, nice and easy. My virtual machine is being a bit slow today. I feel like I should start restarting it instead of putting it on pause mode. And as you can see, we're going to have 8 resources that are going to be destroyed, and that's pretty much all of the resources that we have created. Type in yes, and simply wait for the resources to be destroyed. I believe the longest resource that will take to be destroyed will be Cloudfront distribution, just like it took a while to be created. Fast forward through this, and just like that, all of our resources have been removed from AWS. In conclusion, during this lab, we have configured a simple static website to be hosted in AWS using Terraform. This setup has involved 3 different AWS components: AWS S3, AWS CloudFront, and AWS IAM. We went over and implemented various security features to ensure that our services are hardened and protected from potential adversaries. AWS S3 has been secured by enabling encryption, versioning, and blocking of public access. The only way that our website can be accessed by public is through AWS CloudFront. We have configured this access using S3 IAM
bucket policy. Furthermore, on Cloudfront, we have secured the communication between the client and the server by specifying that only HTTPS protocol can be used for communication. All of this was set up using Terraform, the infrastructure as a code tool, which allows us for rapid deployment and reproduction. If you like this tutorial, please hit the like and subscribe button below. Thank you for listening.